Welcome, welcome. 9.6 in the textbook is called Right Triangles and the Pythagorean Theorem. Um, while I'm recording this video, we have already done some discovery into the Pythagorean Theorem, so we're going to consider that as prior knowledge. And I have broken up 9.6 into two sections for the two different special right triangles. So this video is going to focus on 45, 45, 90-degree triangles, and then the next one will focus on 30, 60, 90-degree triangles. So before we get started, this is assuming that you have knowledge of the Pythagorean theorem. So if you are maybe need to brush up on your skills on that, I would recommend going and watching the video on the Pythagorean theorem first and the Pythagorean theorem converse. Okay. And then here we're going to go ahead and we're going to use that Pythagorean theorem. So I'm going to write it here. So as a reminder, Pythagorean theorem states that the sum of the squares of the legs is equal to the square of the hypotenuse in a right triangle. So when I have a squared plus b squared equals c squared, a and b are legs, c is the hypotenuse. As we go through this kind of investigate problem right here, I'm going to write down things that we know about this type of problem on the right-hand side, kind of like a running list of facts. So first thing first, in this triangle, what do we observe? We have a triangle, which means a polygon with three sides. We have a right angle, right? I also have a 45-degree angle. So what piece of information can I use to find this missing angle here that I don't have represented? Right. So things that we know. We know the interior angles of a triangle add up to 180 degrees. Using that piece of information, right, I have a right angle, which I know is 90 degrees. I add those together, and then I can subtract that from 180, and I get 45 degrees. So I have a 45-degree angle here as well. Something else that I know about triangles is that when I have congruent angles, then the sides across from those congruent angles are also congruent. So what does that look like? I have that angle 45 and angle 45 are congruent. So what that means is that the sides across from them, across from this 45 degrees, is this side 8. And across from this 45 is this side over here. So this has to be congruent. So which means that this is also 8. My goal here is to find the missing sides. I've already got one of them. Well, I also know that if I have any two sides of a right triangle, I can find the third side. So here I'm going to go ahead and I'm going to use Pythagorean theorem. Now A and B must be the legs. So let's go over again, what are the legs of a right triangle? So the legs are the sides that are not the hypotenuse. So I've got this side here. Trying to highlight it. It's a little hard to see. Oh, that's rough. Let me try that again. All right, so these two legs that I have marked in yellow, those are the legs of the triangle as opposed to the other one is the hypotenuse. So if you want, you could label this C, I could label this X, I could label this something else over here. And then I'm going to plug these in. So it doesn't matter which one I call A and which one I call B, they're interchangeable. So 8 squared plus 8 squared is equal to C squared. 8 squared means 8 times 8, which is 64. 64 plus 64 is 128. And when I have 128 is equal to C squared, I want to get C by itself by taking the square root of both sides. When I take the square root of both sides, I get plus or minus some number. So let's go ahead. And when I take the square root of 128, it is not a perfect square, so I will have to do the factor tree. What goes into 128? Well, it's even, so let's start with 2. That gives me 64. Okay, cool. We know 64 is 8 times 8. Let's keep going. I've had quite a bit of practice with factor tree. Hopefully this feels familiar. There's a lot of numbers left. Oh my golly. Okay. Let's count them. 1, 2, 3, 4, 5, 6, 7. So 2 times 2 gives me 4. The square root of 4 is 2. So I have 1 to take outside. I've got another pair. And I have another pair. Which leaves me with 6, square root of 2. So we get this C value of plus or minus 6 radical 2. And then I need to put the problem in context. I cannot have a negative length for C. So when I come up with this final answer, I'm going to have just 6 square root of 2. The side right here is going to be 6 square root of 2, just the positive. So my answers were 8 and 6 square root of 2. Now, I want to also look at this as a table because this can be helpful as well. There are some tactics that you can use for this section, for this type of special right triangle, that don't work for the next special right triangle. So just want to expand our thinking here. We had that one of the legs was 8, right? That was given. I'm going to write it in black. And then we found that the other leg was 8 and that the hypotenuse oh my goodness, I just realized an error. Ah, rewind. Oh my gosh, I get on students for making this mistake and I made it myself. Oh golly. Okay, bringing your attention to this. 2 times 2 times 2. Oh man, that's 8. That's not 6. Yikes. 2 times 2 is 4 times 2 more is 8. That's almost embarrassing. All right. Okay, so what I end up with here is that for every single 45, 45, 90 triangle, it's going to be true that whatever the leg is going to be the same thing as the other leg, right? These are always going to match. And the hypotenuse is just going to be square root of 2 longer than that every time. So let's let that piece of information help us as we do example 1. Find the missing side lengths. Leave your answers in simplified radical form. I'm going to use this table in this explanation, but I'm also going to show you another way that I actually tend to use more often. So, and you can pick and choose kind of what works for you. So if I use this table idea here for example A, okay, I'm going to have a leg and a leg and a hypotenuse. And we know that legs are the same and the hypotenuse is square root 2 longer. So when I work with the information I get here, I've got this bottom length right here is 5. That's one of my legs, right? I don't care which one you plug it in for. Which means the other leg must be 5 and the hypotenuse must be 5 radical 2. That is a super quick and easy way to solve some of these really simpler types of problems. So we would get that x is equal to 5 and y is equal to 5 radical 2. I want to show you another method. So I have another method here that I call the ratio method, all right? And the ratio method can be helpful as well. So the way that I use the ratio method is across from each 45-degree angle, I'm going to put this number in a circle, and I'm calling these my ratio numbers. So across from 45 is a 1, across from this 45 is a 1, and across from 90 is a radical 2. I'm putting them in circles because they're my ratios, they're not my actual lengths. So instead of using x radical 2, I'm using 1 square root of 2. And then what I can do is I can set up a proportion to find any missing sides. I would always put my proportions or my ratio numbers on the same level. So I'm going to put 1, and then I'm going to put the corresponding length underneath it, which is 5. And then let's say I want to solve for y, I would put square root of 2 on top, and then my corresponding length that I'm looking for underneath. Check it out. That says 1 is to 5 as radical 2 is to y. And look, I have a proportion, so I can crisscross multiply and solve. So we do 1 times y gives me y, and then 5 times the square root of 2 is 5 square root of 2. So another way we could do it. I'm going to utilize both ways for problem B as well. I'm going to start with this ratio method that I just used. So the ratio method tells me that across from the 45-degree angle, I'm going to put a 1. Across from the 45-degree angle, I'm going to put a 1. So that goes on both of the legs. And then on the hypotenuse, I'm going to put a square root of 2. Now for here, one of these sides is super, super, super easy to solve for. Look at the problem. The legs are always congruent in a 45, 45, 90, right? This is the same as this. So don't work too hard. Just tell me that B is 3 radical 2. And let's find A. When I set up a proportion, here's my known side is 3 radical 2. So I'm going to do 1 divided by 3 radical 2. And then my unknown side, I'm looking for A, right? So that's square root of 2 on top with the green number on top, and then A on bottom. Crisscross multiply to solve. 1 times A gives me A. Over here, I get 3 square root of 2 times square root of 2. Let's take that slowly. Square root of 2 times square root of 2 is the square root of 4. And the square root of 4 is 2. So I get A is 6. Could I do the same thing with a table? Possibly, probably. All right, you've got options. Giving you tools for your tool belt. You can pick and choose what works for you. So my ratios, the leg is the same as the leg. Those are both x, and my hypotenuse is x square root of 2. Always going to be radical 2 longer. Okay, and I was provided with one of the legs, which was 3 radical 2. So since both legs are x, both legs are the same thing, square root of 2. Then the hypotenuse, I have to multiply by square root of 2. So I have 3 radical 2 times square root of 2, which we already calculated, right? That's 3 times 2, which is 6. You don't have to know how to do it both ways. You just have to know one way. I've always used the ratio method, but sometimes I think this table method is good for organizing information. It can be helpful also. All right, we've got 2 more. These are all a little bit different, so when you're doing your assignment, see if you can find a similar problem on this notes page that could help you, right? So for A and B, your given length was a leg. So I gave you a leg of 5, and I gave you a leg of 3 radical 2. For C and D, your given piece of information is the hypotenuse. So now we're going to have the hypotenuse, and we're going to work backwards a little bit. So I'm going to go ahead and use the ratio method first. And the ratio method says that next to each one of the legs, I'm going to put a 1 in a circle, and then across from the hypotenuse, I'm going to put a square root of 2. These are not the actual lengths. These are just the ratio, because the 45, 45, 90-degree triangles are all similar. All right. So my known side is the square root of 2 divided by 9 square root of 2. So reminder, I'm always going to put the ratio numbers on top. And for me, I'm just using green today, so I'll try to keep that consistent. And then do I want to find M or N? It doesn't matter because they're the same thing, but let's just do M. Okay. and we crisscross multiply. So I have m times square root of 2. And then is equal to 9 square root of 2. Solve for m, so I divide by square root of 2 and I divide by the square root of 2, which leaves me with 9. Not bad. If m is 9, then we know n is 9. Or you can use the table and memorize that a leg is x and a leg is x and the hypotenuse is x radical 2. The cool thing about the table is it's very visual and you might just be able to see the patterns like right off the bat. So for this problem, I was given the hypotenuse, right? This is my given right here. So I'm going to write that in the hypotenuse column. Can you just look at that and tell me what x must be? Yes, it just has to be 9 and 9. So then I would get my answers. All right, let's do another one. D is going to be slightly more complicated because of the numbers that I chose, and it's all on purpose, so hang in there. All right, so each leg, U is a leg, V is a leg. I'm going to put 1 in a circle there, and then my hypotenuse square root of 2. And I'll set up my proportion. What should we solve for, U or V? I think I like U better. I'm going to go for the U. So what do I know? I know 12. What's the ratio number associated with 12? Square root of 2. I'm going to look for U. And the ratio number accorded with that side is 1. All right, so I cross multiply, and I have U times the square root of 2. Notice I put the variable or the number first, right? The radical goes at the back, and 1 times 12 is 12. Here I divide it by square root of 2, and I divide by square root of 2. And I get U is equal to 12 divided by square root of 2. And then we ponder and wonder, how can we simplify that? I have a 12 outside the radical and a 2 in the radical. I can't simplify that. And then maybe you remember, like, oh, there was this thing called rationalizing the denominator that we did briefly. Let's bring that idea up. So rationalizing the denominator means I don't have a radical in the bottom of a fraction, right, in the denominator. So to get rid of it, I would multiply by the square root of 2 on the bottom, and then whatever I do to the bottom, I have to do to the top. This leaves me with 12 square root of 2 divided by square root of 2 times square root of 2 is square root of 4, which is 2. And how do I simplify that? I can simplify the whole numbers, and I get that U is equal to 6 square root of 2. Well, if U is 6 square root of 2, what is V? It is also 6 square root of 2. In this problem, I think the ratios are more helpful. But let's take a look at the table in case you've decided that seems like it's best for you. Now, this rule of x square root 2 will only work for 45, 45, 90-degree triangles. The rules are going to change when I have different kinds of triangles. This time I have the hypotenuse is 12. So you may think of going from the hypotenuse to the leg as dropping the square root of 2, but we can't just like cut it off. What's happening is that we're dividing by it. So the work here becomes 12 divided by square root of 2. And then I would just use my rationalize the denominator the same way I did above. Is 6, oops, let's jump on the gun. Hold on. 12 square root of 2 divided by square root of 4. Square root of 4 is 2. And then that simplifies to 6 square root of 2. So both methods work. You don't have to do them both. You can use them both if you want to use the table where it looks convenient, and then if it's not convenient, use this ratio method of setting up a proportion. Then you can do that. So, all right, that wraps up 45, 45, 90. In the next section, when we do 30, 60, 90, the problems are a little bit more involved. So making sure you have a great grasp on this first is definitely going to help you for the next section. All right. Thank you. Bye-bye.